decompose functions by using orders of pairs. So composition of functions is plugging one function into the other. So taking all these x's of this one and plugging them into the equation of f. Okay, so f of g, this says f of g of x, or f of g of x. So it could look like that, meaning I'm taking my x of g and plugging it into the g equation, and then taking that answer, that y value, and plugging it into my f equation for x. So what that looks like is taking each one of these, so doing g of 4, and g of 4 is 1, right? Because I plug in 4, I get 1 out, and then using that 1 and plugging that into the f equation. So f of 1, plugging in 1, I get 12. I get 12 as an answer. So f of g of 4 equals 12. I plug in 4 into g, I get 1 out, and then I take that 1 and I plug it into f, and I get 12 out. So f of g of 4 is 12. So I get this point for f of g of x. The first one is 4 is for my x, and 12 is my y value. Okay, the next ordered pair is plugging in 5 for g, so g of 5. I plug that in and I get an answer of 0 out. Or I'm just using that ordered pair. Now I'm going to take that composition function, plug that into f. Well, f of 0, so if there's 0 right there, I get 13. So that means f of g of 5, I get 13. So when I plug 5 in, I get 13. And then I just keep on repeating this process. So I plug in 13 in for g. So g of 13, that y value is 9. And now what is f of 9? And f of 9 is 7. So I get 7. So f of g of 13 is 7. So when I plug in 13, I get 7. And then when I plug in 12, g of 12, I get 10. Now what is f of 10? f of 10 is 11. So that means f of g of 12 is I get 11. So I plugged in 12 and I get 11. That's the last one. So that is f of g of x. So my domain is all my x's, so that's 4, 5, 13, and 12. So if you notice those, the domain of this is 4, 5, 13, and 12. Okay, and you notice those are all my x's of my g. And then my range are all my y values, 12, 13, 7, and 11. And you notice those are all the y values of my f. And that is the case. So then if I was to do g of f of x, meaning I'm taking f of x, finding the answer, what my y value is for f of x, and then plugging that into g. Okay, so you'll notice that is going to be, my domain is going to be my x's of f, so 1, 10, 0, 9, 1, 10, oops, 1, 10, leave some space for my y's, 0, and 9. And then we'll see what we get for our y values. So we're going to do the same process except for with, start with f of x. So we start with f of 1, and we get a 12 out. Well, what's g of 12? Well, g of 12 is 10. So we get 10 out. So we started with 1, and we plug that answer into g, and we got 10. So this is 10. Then we plug in 10 into f. We get 11 out. Then we plug that 11 into g. It goes from inside to outside. And when we plug that into the outside G11, we don't have a G11, right? So there's nothing there on that one. We don't have an 11 for our X, right? So that means we don't have that Y value's not in there, right? Okay, so we'll address that later. Let's move on. Now we plug in 0, f of 0, and we get 13. And then can we plug in 13 in for G? Yep, we can. It gets us 9. So G of f of 0 equals 9. So we plugged in 0, we got 9. And then 0, 1, 10, 0, and then last one is f of 9. We get 7. And what is G of 7? There is no 7 in here either, so we don't have that in there as well. So that one and this one do not work. So since they do not work, that means that these will not be in our domains or our ranges. So our domain for this one is just 1 and 0. Set notation. So 1 and 0. And then our range is our y values 10 and 9. And so that's how you do it with an ordered pair. It's inside out. So you start with the inside 1G, and then plug in your X, find out your Y, and then take your Y value and plug that into F as your X.